Hello, hello, hello. Excuse me. Babs coming at you with part 3 of the ADSR expanding list series. And first thing I'm going to do is mic, test, test. I can never actually hear that. I'm just kind of going off intuition. Uh, it's the early morning. I'm just drinking some tea, relaxing. Oh, the tea's damn good. And I don't know where I left off in part 2. I feel like I did a lot of work off scenes, off camera. So let's let's show you what I implemented, huh? So I actually got an attack, and I can actually click here and get a menu, and I can set my attack. So that's working. The only thing that isn't happening is that I'm changing the currently selected item, but I'm not actually grabbing the index number, which is actually the actual attack value. So that has to get implemented. But I'm very happy and proud to have come this far. Um, and all that I ended up doing was, in the last two videos, I was going back and forth. I wasn't sure if I need to derive from the context menu or not. The answer is yes, I ended up deriving from it. Honestly, these functions here should go into the context menu. These are just some simple stuff that mess with the Boolean from context menu, so I'm actually going to put them back here, which is where they truly belong. Same thing with these functions here. Just throw them right here. That's that. Basically how it works is the preload is called when we do our first iteration of the draw function. As you know, I have this Boolean value for all these like high-level window classes is first run, and so it's set to false at initialization. And when we first enter our quote-unquote game loop, we check to see if it is our first run, and if so, we do some first run calculations. And in the draw routine or the run routine, that is usually calculating the proper x and y coordinates of certain elements that will be displayed on the screen. So one of the first things that ends up getting called is at the appropriate x and y, the expanding list preload will be called at the appropriate x and y coordinate. And that's like a one-time thing. In contrast to the context menu, which is always called, well, when I'm talking about right-click context menu, which would be called, when the user right-clicks, we grab that x and y, and we call it all the time when a user right-clicks. And the other thing that's different is that unlike the context menu draw routine, which will only draw if it's active, what happens in the expanding list is that we'll only draw all of the displayable items when it's active, but if it's not active, we're going to draw, I added an element called currently selected item, so we draw that at the proper place. And then I also made some adjustments to the rect where all the items are drawn will be below the selected item. Let me be visual about this description. So what happens is, notice that this says 4.1 seconds. When I click, I made the behavior happen that the 4.1 goes away, and then we see this entire menu of everything in the proper order. And then you notice how I clicked here, but the menu showed up at the next tile height down from the actual menu entry here. So that was some custom behavior that is part of the expanding list and is not of the context menu itself. Another thing that I really want to incorporate, and this needs to go in the to-do list because I can't remember everything I say in these videos. I don't even go back to these videos. I talk about so much content. It's really too much for a direct reference. But what I really want to do is context menu, expanding menu. I want to draw onto a different surface, like draw the menu on a different STL surface and then blit. This is to avoid you know, this is to avoid crap happening when we draw on stuff below us. You know what I mean? It just kind of uses it. I don't know if it's performance-wise the best, but so yeah, I got that going on. And like I said, the next thing is to actually obtain a value. Now, one of the simplest ways to do this in the context of an expanding list is to utilize the function pointer. See, we have this thing. I'm trying to look for it. See, we have this thing happens where a do thing function, where the highlighted item we will call their function pointer. Now we could also keep an index and not even have to worry about that. I'm thinking about doing that. So I'm thinking about having something like int currently selected item index. And with this, whoops, we want to look for that highlighted item. Where does it get assigned? It gets assigned here. That means that the currently selected item index equals I. At this point, we don't even have to mess with the function pointers. See, I was going to make all these different functions for all the different entries that would, take in the address of a index variable, but don't do that. We can just do this. Okay. And at this prototyping stage, I'm still using the expanding list with the clickable text items with their function pointers and all that crap. That's really not necessary. That could be taken out and minimized. But see, at the prototyping stage, you never really know what you're going to expand and desire later. So it's better to leave all that functionality and capability there. So that's what I'm going to do. So, these don't use the function pointers, but I'm going to leave them there. Keep things nice and simple. It's prototyping level. So now that I get that index, I'm ready to kind of implement the next part, which is the decay. We'll do the decay. This tea is so good. It's like Lipton black tea. I put some milk in it too. Yeah, my girlfriend don't like it with milk. She hasn't even tried it yet without the milk, but she should. Anyway, so I kind of wanted to talk more about that abstract creation of a context menu, because a lot of things I have to perform manually that has the capability of being automated. I'm talking about this stuff. If we go to the instrument window, stuff that could be automated is like we want to create a context menu to have like a program automatically make this struct context. I tell it the name I want to give it, it automatically inserts a menu of the proper type, context. It's going to be tough. You can't really, I'm not automating that crap. I'm just going to do it manually. But this is the kind of crap that I want to, this is really an attack context. And then I'm going to make a decay one. This kind of thing might want to be abstracted outside the instrument window and maybe put into its own C++ and header file. Maybe even an ADSR.h and .cpp. But for the meantime, I'm just writing it, prototyping it in the instrument window. There is some pre-calculating that I'm doing manually here. I don't really know what it is. Need to get to ADSR. We want to make sure that these variables are used across. So like this. The decay map is 8, so we will take that value and we will variabilize it. It should be decay map, right? I think it should be attack map size. So that's what I'm going to start using. I need to go into the expanding list here. No. This should be attack map size. Once again, we add one for the empty list. Sustain level map is 8. And the sustain release map size is 0x20. Okay, cool. This is my decay context. We'll call this decay. Check this. See, I need to kind of manually already know what these values will be. Even though I've kind of abstracted the value here, that's not good enough. I mean, and these values will never change, so this isn't a problem. But yeah, the decay map is 8. And that's what we will write. We will use 8 and the rest go away. Just thinking to myself. So now that I have this, let's take a look at the code of instrument window. make sure we save. In the instrument window, we're going to look for the attack stuff. Here's where we actually initialize and write the attack. So what we want to do is we want to take the sterling of attack and we want to add that to x coordinate plus a couple, like 2. So let's just do this for example here. Now we're going to do this. In I don't know, decay x equals x plus char width times 2 plus sterling attack. And then we'll just use the same y. But we don't want to use this y. We want to use the... What? What? No! What's she thinking? I told her let's wait till everyone wakes up. Say that not. No, whatever. I'm pausing this. So I'm trying to get the y at this point here, so I want to say like, I don't know, just save it. Doesn't have to be too complex. Wait a second. Yep, that's right. And I'm gonna use this now. What's this attack.x? I mean, is that even used? I'm gonna keep up with this fashion and just keep using that crap. In that case, I can just do this. At this point, we gotta do like y equals char height plus and now let's do some more searches for attack. So here we're going to do the decay context, menu, draw screen. Let's do some more, okay, and then we're going to do all this crap. I think it's time to start putting this in a function. just to, I mean, get me organized, you know what I'm saying? But at the same time, I'm too lazy for that. Plus, I mean, I don't like the idea of calling these functions and checking booleans just to return. Isn't that kind of like non-optimized behavior? I don't know if I'm being too picky there, which I feel that I am. I'm just going to take the risk and put this in a function inside the attack context menu. I'll just call it, you know, receive event, which basically brings me down to attack context menu dot receive event. You can just pass EV, and that would make me call the decay context. Now let me see what I can do here. Context menu. What do we use here? We use void STL event. So, you know, let me give this a shot. Void receive event. Oops. STL event. Void context menu receive event STL event. Oops. Okay, then we copy all this in, and now what we want to do is we just want to say F is active. How about if not is active, return, and then we'll just keep all this crap like that. What is that switch? We don't really need that return, but I'm going to leave it there. And then here we just say do thing. Deactivate. Molly like that. Let me see if I can make this at this point. Yeah, my debug messages flirt with me at this point. Attack size, ADSR.h. Get out of here. You're in my way. A couple errors here. No member named attack size. That's fine. Instrument window.h. That's because it is in attack map size. Let's see how that handles. Use of undeclared identifier quitting. That's in the context menu. Use of undeclared gconfig. I think this is all part of the debugger. Yeah, so these context menus are going to have to be able to access, and fortunately I can just hack. I don't need to like make it official. I can just, this is a static class, I can just use it. So I will just use it. I think I can just do that. Anything else? The gconfig. Wait a second. This is wrong. Something's up. What's going on? Dude, seriously, what's going on here? Oh yeah, these need to get called. We should make a function here that actually gets called within the menu, so this should be called like, I don't know. I don't know what to call it. Collision check? I just call it collision check. It's kind of a radical, I mean, it's a left click collision check. So we can really end up calling it like attack menu, attack context dot menu dot left click collision check. The only thing is that being a high level, I can actually do other things. So I'm going to leave it like this. This should be an else. Didn't I take out that start stop crap? I don't know. But anyway, else. So we'll just go and decay. No, we gotta find the word attack and switch it with decay. What else is wrong with this picture? Let me see if I can just say that normally shouldn't be a part of based. That should be pulled out, made more global. That's an app level. I think quitting should really go into like an app. Maybe app should be static class. But we ain't talking about that yet. Ooh, this almost works. Does it work here? I basically broke it somehow. Let's see what I did there. And why is this way over here? I broke something somehow. This was working before. I would just click. Now it'll be that. But now it's just showing the wrong one. My bird is so annoying. He wants attention. Sorry, bird. My poor bird. I'm doing a video right now, yo. This is the part right here. Shouldn't this be working, yo? It's not working. We gotta figure out what's up with that. I know the problem. I know the problem. It's gotta be here. Normally we return I hate to do this, but I'm gonna do it. What? Ready. Okay. Okay, it's been nearly a whole day since I paused this video. A lot of stuff happened in between. For instance, I'm in the middle of reverse engineering the Presonus Firebox SPDIF/MIDI serial input thing, and I'm using an M audio cable to connect to it because I got it for 75% off what a replacement for the Firebox would have been. I also got a MIDI cable, so I was messing around last night using my DAW, my Firebox, to do MIDI out from my Mac to my synth, and it was so cool because I've made a lot of like compositions in MIDI, and now I can use it to drive my synth. It's so much fun, but nothing to do with SNES Tracker. So I also did a lot of development this morning on SNES Tracker. I don't remember where we were at, but I fixed everything and improved, made new things happen, and now this is where we're at. You can actually go in here. We've got an entire thing that represents, you know, all of the voice's current ADSR envelopes you can cycle through. And I went to start playing the instrument or the voice, and I can actually adjust the attack. So check this out. Versus 0, which is, you can change the sustain. Now I want to talk about this sustain level because it's kind of deceiving. What it means is, I understood this when I looked into it like an hour ago. What happens is, so I'm just going to explain them all, and hopefully it'll help me get to that part that I forgot. So the attack is how much time will it take to get from 0, we're talking volume, this is all volume, from 0 to you know, the height of the volume, the highest it can go, right? So we'll say, you know, this will take 2.6 seconds. That was the entire, we just heard the entire 2.6 seconds, and then we heard the rest of the envelope, which was unexplained. So what happens then is once we reach the highest that volume can go, from an envelope, you know, that's 1, 0 to 1, but technically the value is going to be specified by the voice's volume registers. Once we hit that highest level, we're going to go into this decay, which means how long will it take to reach the sustain level. Now these two go hand in hand, because the sustain level, if you make it I think 8 out of 8, it means that shit, how did I do this? Let me play it. Let's do a fast attack. Immediate. You see how that's so sudden? But for instance, let's do a sustained release at 2 seconds, 2.9. Hold on. One. Let's mess around with this, see if, because I'm lost. Is that right? I'm so lost right now. It doesn't seem to matter at all. So strange. But what it means is, and there's a graph that really helps, is there's a sustain level that we define, which is a fraction of, I think, 1. So we can decay to whatever value we specify as a sustain level. The thing is that if we specify 8/8, which is really just 1, all we're doing is kind of going to be at the same volume there.
but we specify a sustain level. Maybe we do a little less than 1, and how long will it take to get to that sustain level? And then once the sustain level is reached, I think we go into the sustain release mode, and that's how long for the time from the sustain level to 0 will it take. Now, that's exactly it. I just nailed it theoretically. Let's mess around with it in practice and see what happens. So let's say we want to sustain for like no time at all. But that wasn't 1.2 seconds of decay. See, that's where I'm lost. I didn't hear 1.2 seconds of decay whatsoever. But if I go to 1/8, we heard a lot more sound. You see what I'm saying? So I'm really confused. I think what happens is the decay is a lie. Time from 1 to SL. But I think that's a total lie. And we're going to look at falseness to diagnose this. Falseness is the balls. So falseness says for the decay rate, see, this is a rate. We increase the decay rate. I want to make sure that I have this right. Yeah, we increase the that makes sense because it's going faster and faster. Still, what happens? What actually happens? It's described in here. So once the level hits the max, we switch from the CAC to decay mode. And then when the level is less than the boundary, switch from decay to sustain mode. And of course, that wasn't explained very well, because I'm trying to, I guess those timings are messed up. So the only way to really solve this problem would be to do the math, which, you know, I barely understand. Rate equals n times 2 plus 16. But what unit is this rate in? What is that? I don't even know what this shit is. Step equals level, yeah, whatever. Must be steps. The rate must be the number of steps. But I'm not putting this together. Okay, I'm trying to put this shit together. A true diagnosis would take a lot of work, effort, programming, you know, to actually get real timing accurate reports. Let's see if we can not do that. Sustain release. This goes lowest 18. So I guess this is the timing according to a 1/8 sustain level. That's my guess. Because if we go all out, like, let's just go, you know, that was not 1.2 seconds to the sustain level. Not a chance. What I think happens is that we're at a certain rate here, and the rate is going down to this level, and it happens fast enough that that level is hit before this value. This must be a max value at this point, and then we go into the sustain release mode. And it's very obvious that we went into sustain release mode because it basically kills that shit. set it to a very fast release. So I think I figured it out vaguely. That that isn't scientific right there. So yeah, that's kind of lame. Time from 1 to SL. But that's a lie. That's time from 1 to 1/8 SL, I think. And of course, there also could be issues with my programming. Maybe I have the wrong bit masks or the wrong registers. So I'm going to take a look at them. So we have sustain level, sustain release, but we're looking at the K. It's the decay and the sustain level that we need to analyze right now. There's a lot of functions. So let's look at the decay mask. The decay mask is 0x70. And it's these top three. And that's correct. And it is right there. So let's look at the sustain level. E0. And that's right. Let's look at full SNES. Well, let's look at those functions actually. I have those reverse functions. Do I ever use this? This update function. That gets called correctly, I think. Yeah. I think I was right, and then now I'm kind of going away from being right because, well, I guess I'm not sure. Man. God damn it. Oh yeah, I wanted to look at the bits here. Well, everything's right. I've got all my shit right, so I guess I'm right. I'm not sure that I got all of my shit right. The code base is really big now. But I'm pretty confident. I mean, I read the correct DSP values, and when I set them, attack change, decay change, we'll take a look at those. which are probably in the ADSR. That's all correct. So in that case, I think I'm right. I think I'm right about this. 1.2 seconds at 1/8 sustain. Whoops. Oh, let's turn this down to... I wish I had a little clock open and I could maybe... Like I said, I'm not going for that official measurement. I'm just too lazy. But I can get a clock and kind of... This is only good. This is only good. I don't know. That wasn't 1.2 seconds. Fuck did it. This is a lie right here. We're looking at a lie. Maybe it meant at 0. 1.2 seconds on a 0 sustain, because I'm not seeing anything else. And then yeah, if we go all the way up to 8 or 7/8, it's not taking 1.2 seconds there. So what's up with that? Yeah, so I guess that's just gonna have to be experimented with. But that's definitely a lie. I wish I had a way to you know, instead of saying 1.2 seconds, which is very misleading. I don't know now anymore what this is. All I know is that the sustain level messes with that. Watch, we'll do it. We'll do it. See that? Very, very strange. Let's do it with low. Same shit. Huh. I don't know, guys. I don't know. I think what I'm going to do is I'm going to take a separate video that's much more truncated, and maybe send that off to NestDev forums, and maybe we can get a smart response from someone who's done research on this stuff. Alright, I love you guys. See you later.